Myself Parikshit Mateda from the Charutar Institute of Science and Technology. My department is IT and my ID number is 24IT049. Subject code CSU101 Digital Electronics. Now let us deep dive into my top today's topic, digital stage lighting control, sequential circuit in light patterning. The art of illumination, digital lighting in modern stage productions. The digital lighting transforms the stagecraft with precise control, and sequencing enhances drama, mood, and guides audience focus. It allows dynamic cues, rich color, and palette at instant and changes. Now, let us further deep dive into the technical aspects of this topic. What is digital lighting control? Now let's understand it. The digital lighting control automates the light pattern as we can see in the stadiums and many of the amphitheaters where we can see the light patterns and effects. This all it uses an electronic circuit and software for precision. Further, the system integrates input from the console to control brightness, color and movement seamlessly. These are the major aspects of lighting control. In addition to it, control consoles allow operators to program cues, scenes, and transitions efficiently. And furthermore, if we talk about, let us understand about a sequential. What is a sequential logic? A sequential logic in digital electronics is a digital logic with memory that stores the past inputs. Like for an instance, at Q0 or at Qn, I have taken the input as 1, and at Qn plus 1, it will it will store the past input as 1. We can see it with many of the flip flops. Like one of the major example of it is, particularly if I can remember, is the D flip flop. It uses to hold the state and enable state transitions over the time. This allows systems to remember events and react dynamically in the stages. Now let us understand the sequential logic in more details. The sequential logic stores the past inputs, unlike simple combinational logic, as we have already mentioned. Flip-flops are memory elements that hold the state over the time. They enable the state transitions, like from set to any other state, allowing circuits to remember events and sequences. And why to use the sequential circuit for the lightning. And there are the four major aspects of seeing or learning the lightning sequential circuits for lightning. The four major, we can say, the pillars are precise timing, automation, synchronization, memory function. Now let us understand the first aspect, or the first pillar is precise timing. It enables exact control of light changes and transitions. Another, or we can also say, it is one of the most major benefit of it. Further, the automation automates complex queues, reducing manual operation errors and many other things. Synchronization, one of the most major aspect of it, coordinates multiple lights for seamless and unified effects. As we already know, we have seen in many laser shows and lightning shows at our surroundings. In addition to it, the memory function, one of the most major and one of the most important aspect of it. It remembers the previous state for the smooth scene progression. This is because the memory function continues the cycle, due to which we can see the lightning effect. Now let us understand what is the role of digital electronics and various components of it in the sequential circuit for lightning. In it, first of all, let us understand in before that, let's understand the sequential versus combinational circuit. The sequential circuit have memory outputs which depends on past and current inputs. And if we talk about the usage, then sequential circuit are vital for automated lightning sequences, as we have mentioned earlier. And unlike the sequential circuit, the combinational circuits have no memory, and the outputs depends only on the current inputs, or the timing or rate or the amount of current which is passed. Further, Unlike the sequential circuits, the function of combinational circuits are instantaneous. Like combinational circuits handle at instant logic-based decisions with no storage. Let us now understand the key components which are used in the digital stage lightning for which includes the major role of digital electronics. There are three major components which are included in the circuits. The 555 clock timer, or we can also tell is 555 time clock. The function of it is it generates a continuous stream of electrical pulses or clock signals. Where if we see in any software, electronic software, then we can also see a square wave, which is for formation of the square wave by the 555 time clock. The use of circuit, use in circuit, it controls the timing speed of LED switching, which is already written here. Further, the what is the effect it creates? It example of its effect, it faster clock, faster LED chasing. And now you will ask, what is LED chasing? The LED chasing is a concept in which the frequency and the illumination of light is changes, and illumination of light is changed at a particular instance of time, like fading of light or faster blinking of light. These are all the examples of faster chasing of light. Further, 4017 counter, this is also a very important or significant part of our circuit. The function of it, it advances its output high one step at time on each clock pulse. So basically it is connected with 555 time clock. Further use in circuit, the use in circuit, it lights up the LED in sequence and one at a time. Further example effect creates running light or chaser effect. We have understood it. Further, we have to see 4-bit universal register. Shift registers. The function, it moves data bits from one output to the next in sync with the clock. In addition to it, furthermore, now let us talk about the shift registers. The registers has the function. Let's first of all talk about its function. The function of it is it moves the data bit from one output to the next in sync with the clock. The clock at this instance we are talking about the 555 time clock, which continuously signals or generates the electrical pulses, which are also known as the clock signals. The shift registers work in sync with these clocks. The use of the shift registers in the circuits are they essentially play the role in controlling the multiple outputs using the fewer pins. And example of its effects are the rolling or bouncing light effects. Now let us understand about one another major components of our digital electronics. The major component which is presented here is the D flip-flop. The D flip-flop are basically the function of it are we can say it stores one bit of data and changes the state on clock edge. The clock edge is once again these are the timer clock which is here represented as the CLK pin, which is connected in the D flip-flop. The uses of it in the circuit are it forms the memory element or basic sequential logic. The example effect of it is used to create or build counters or detect patterns. So basically the D flip-flop can also be used as a replacement for the counters, 4017 counters, like 4017 counter particularly, as we have seen in the past. Okay, the next is the components required. The major this is the circuit. This is how the basic circuit of the digital stage lightning of the 10 LEDs looks like. Now let us go into the component list, which are the major components used in it. The first is 555 time counter, which is an astable mode to generate the clock pulses, and CD4017 decade counter IC, which receives clock pulses and sequentially activates its output pins from Q0 to Q9 as mentioned in the diagram. Further, the LEDs. These LEDs are connected to the output pins to display the chasing effect, and the resistors. which are the current limiting resistors for LEDs and timing resistors for that 555 timer, capacitors for timing and stability, and power supply typically 9 volt or a range of 9 volt to 1 volt to 0 volt to 9 volt, or typically a 9 volt DC adapter is okay. 0 volt, typically a 9 volt DC battery or adapter is okay for the power supply. Now let us understand about the working principle. The working principle of this circuit. This is one of the most important part of this video. This is the one of the most important part of this video. The triple five, let us first step is to understand how this triple five timer contributes to this circuit. The triple five timer is configured in astable multi-vibrator mode, producing continuous square wave pulses. It continuously goes high to low, creating a square wave pulses. These square wave pulses are fed into the CD4017 decade counter IC, and we have seen the function earlier of it, how it works. So as a result of it, this decade counter IC when receives the square wave pulses, with each pulse the counter advances to the next output pin and turning on the corresponding LED, as the LEDs are connected with the decade counter IC, and this creates a sequential lightning effect, commonly known as a chaser or running effect. Now let us understand by the truth table of 4 output LED chaser truth table. This the first column indicates the clock pulse, the second Q3, Q3, Q2, Q1, Q0 and LED pattern. As you can see here, at every clock pulse, at every clock pulse, the different LEDs are on their high state, and after the fourth LED is on, the repeat work goes on, and this is where the work of D flip-flops and counters are very much essential. It is essential in the whole circuit or in the whole process, but it is very much essential in the repetition also. And furthermore, if we talk about the truth table and how this circuit works, from Q0 to Q3, these are the output pins of CD4013 IC. Each pin can either be high 1 or low 0. Clock pulse. Each pulse from the 555 timer advances the high signal to the next output pin. And LED pattern. The high signal corresponds to the LED that is on. The LEDs light up in sequence, creating the chaser effect. Further, now understand about what is a D flip-flop, and now let us understand more into what is the functioning of D flip-flop, how can we use it, or how can it be the alternative to the 4017 counter in a digital lightning circuit. A D flip-flop or data or delay flip-flop is a digital memory element that stores one bit or data. It captures the value on the D data input at the moment of the clock stage, as we have seen the CLK pin earlier, which is the clock stage, and D is the data input pin, and passes it to the Q output pin. Let us understand its uses in the light pattern circuit. Building custom counters. You can connect multiple D flip-flops in a series to create binary counters, basically divide by 2 or divide by 4, etc. This can replace or supplement ICs like 4017 if you want to design your own counting logic. Now let us understand about, or let us see the cycle example of the working principle of LED chaser clock pulse, basically the 555 timer. Here the truth table is given, how the LED, how at the corresponding clock pulse, how the LED goes high, and the let us now understand about how the signals are passed in this circuit. The 555 timer is set up in astable mode, producing regular square wave pulses. This pulses acts like a rhythm or beat for the lightning sequence. Counting outputs 4017 decade counter. The 4017 IC receives the clock signal at its CLK pin. With each pulse, it activates one of its 10 outputs. Q0 to Q9 in order. It goes in order or it goes in the sequence. Lightning the LEDs. Each output Q0 to Q9 is connected to an LED. Only one output at a time is high. Only one output is high at a time. So only one LED is on at a time. After the Q9, the counter resets and starts from Q0 again, which is again a characteristic of 4017 counter. Now, all in all, concluding this topic, let us understand about the real world use case sequential lighting in concerts. Sequential lighting creates dynamic light sweeps that follows the music rhythm of fade in effect gradually brightens sections of light enhancing dramatic scenes. This technique guides audience focus and amplifies the live atmosphere powerfully. Basically, it is a tool or it is a very important uh, circuit or very important it plays a very important role in aspect of the entertainment also. Let's see about LED fading and blinking using the PWM and the timing logic. Now we have seen how the circuit works. Now let us see the different effects as we have seen the chaser circuit. Now let us see how the different fading and blinking of light occurs by pulse width modulation. The pulse width modulation PWM. PWM varies the LEDs on time to control brightness smoothly. Fading effect. LED brightness increases or decreases gradually using the pulse widths. The pulse widths are created by the timer, 555 timer. Blinking effect. Timing logic switches the LED fully on and off at the set intervals, which can be done with uh, many components like counters or D flip flops, as we can build a custom logic by the using with the help of the D flip flop also. Okay, now let here the table is also given of effects, methods and components. For blinking we can use clock pulse, 555 timer resistor. For fading we can use PWM vary duty, microcontroller, 555 in PWM mode. Now let's now see the block diagram overview. The simple sequence represent the flow of digital lightning control, which have clock, sequential circuit, driver and LEDs. The simple sequence represents the flow of LED lightning control. Clock generates time pulses for synchronization, generates the time pulses for the synchronization, and sequential circuit processes inputs and controls the output states, as we have seen what which are the components and how the sequential circuit works. The driver, the new, here we can see driver is one of the new component. Let us understand it. It amplifies the signal to power the LEDs, and LEDs as we all know and LEDs as we all know, the visible lightning element responding to control signals. The definite here in in this diagram we can see the synchronous sequential circuit, which is run by a clock signal. Let us now understand about limitations of solutions in sequential lightning. Now let's understand the limitations of analog control and advantages of digital control. Why to use the digital logic or digital control? The one of the some of the major limitations are of the analog controller: limited lighting patterns available. Second is manual reconfiguration is time consuming, and the third is lack of dynamic flexibility during performances. Some of the advantages of digital controller: microcontrollers enable programmable sequences, flexible adjustments of lightning patterns in real time, easy integration with the modern stage autonomous systems. But both the analog control also has its own advantages and digital control also has its own advantages and limitations. But all in all, analog controls has more limitations than the digital control. Furthermore, let us talk about concluding this topic, empowering the lightning creativity. Sequential circuits offer affordable, robust lighting for dynamic stage effects. They enable creative, programmable light sequences without complex software, ideal for students, hobbyists to explore practical digital logic application. This knowledge unlocks new possibilities in stage design and automation. RGB lighting, this is a great example of the sequential circuit. And all in all, for last of all, in a nutshell, I would like to conclude my topic and say thank you. I appreciate we all of you. I appreciate your time and interest in digital lightning control. Feel free to reach out with questions and collaboration ideas with me. Thank you.